Hi everyone, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. So everybody do let me in the chat box if I'm clearly visible and audible to all of you so that we can start with today's lecture, that is comparison of acidic strength. Okay, right everybody? And basicity I'll take in the next class because my health was not fine, so I think acidity plus basicity will take around 3 hours or 3.5 hours to cover. So that's why today I'll take only acidity, tomorrow I'll take basicity, right? Okay everybody, and after that we are going to start with isomerism, right? Yes everybody, do let me know in the chat box if you are ready for today's class. And before that guys, let me see who has done the homework. So Rama Raju has done the homework, and I just checked Swarna has also done the homework when I messaged you. So very rare students, they do their homework, right? Very rare students, right? That's not a good part, that's not a good thing on your part. So everybody start doing your homework, that will be beneficial for you only, right? Now the homework, the answer is D is the correct answer. They have asked the most stable carbocation, right? And what you will see that here you will have more like extended conjugation in this case, right? That's why this will be the most stable. So D is the most stable carbocation, right? Okay, yes. So now, and before going further, right, how many of you have registered yourself to MVSAT program? It's very near, right? 4th, 5th, 10th and 4th, 5th, 11th and 12th of October. These are Saturday and Sundays, right? Now in these days, we are going to take your MVSAT test, in which, right, if you are among 2.5 lakh students, you will get, yes, you will get 100% free education. That means 100% scholarship on all the courses of Vedantu, right? 150 crore worth of scholarship and 2 crore worth of cash prizes and rewards like iPhone, iPads, drones, all these things you will get, right? All you need to do is register yourself. Registration is also totally free of cost, right? Just register yourself and give this test and see what miracle is going to happen. And after that, personalized attention will be provided to you, one-on-one counseling will be provided to you, whether you're in class 11th, 12th or a dropper, right? Full dependency you can have on us, right? Okay, yes everybody. So let's start. Thank you Guru Raj, Rama Raju, Swarna. It's me, Deepa, Amira, yes. Okay, so let's do this, right? Firstly, tell me what is an acidic strength? Little bit I have told you before also. So acidic strength is, if you have HA, right, that is an acid, right? And here what is happening? It is able to lose its proton, right? If the carbon ion that you have formed is stable, then this will be a good acid. If this is not stable, this will be a poor acid. So that means all we are looking for is the stability of carbon ion. Stability of carbon ion is what matters the most to us, right? So we are going to focus on the stability of the carbon ions, right? From that we can tell whether it's a good acid or it's not a good acid, right? So full focus will be here, right? What is the stability of this carbon ion? So one by one, first I'll start with very basic questions. Then we will move towards carboxylic acid, benzoic acid, phenols, right? Because so many things we'll learn in that, right? And that thing is only possible if you start from the basic of acidic strength, right? So starting with the basic of acidic strength, first is we need to understand what will happen to acidic strength along the period and down the group, right? Along the period and down the group. To explain that, I'll firstly write it here, right? That what exactly is going to happen if you go along the period. Along the period, and if you go down the group. Down the group, right? So along the period, the factor that you will consider here is electronegativity. Is electronegativity, right? You will consider electronegativity along the period. And down the group, you will consider the size of anion. Here you will consider electronegativity of the anion that you will have after you lose H positive, right? Okay, tell me. After you lose H positive, the electronegativity you will see along the period, and down the group you will see size of the anion, right? Let's see how. Now if you see, this is fluorine, chlorine, bromine, iodine. This is down the group. Fluorine, chlorine, bromine and iodine, right? This is down the group, right? Down the group, I told you, you need to consider the size, right? So if you see the size increases, that means if the size is increasing, fluorine, chlorine, bromine, iodine, we know that the HF will be like this. HCl will have a bigger size, that's why the bond length will be more. This is HBr and this will be HI, right? So it's actually not like this, I am just visually representing that how it should be like, right? So here, because the size is small, here size is big, then even big, then even big. That is the reason you have these kind of bond lengths. Now if the length is short, it is very difficult to break it. If it is difficult to break it, that will be a very weak acid because it will be very difficult to take out proton from it. So that is the reason to break these bonds, we know that HI is the most easiest one. That's why the acidic strength order will be HI, HBr, HCl and HF. And down the group in the hydrides, always this is going to be the acidic strength. Right everybody? Now let's talk about the second one. Now let's talk about, this is, if you see this, this is fluorine, oxygen, nitrogen, carbon. Can you see this is the group, this is along the period, this is carbon, nitrogen, oxygen, fluorine, right? So that is along the period. Along the period. And along the period, what you consider is electronegativity, right? So here you are going to consider the electronegativity of the elements, right? If you see the electronegativity of fluorine is maximum, it's like this. Carbon, nitrogen, oxygen, and then you have electronegativity of fluorine, right? If the electronegativity of fluorine is maximum, now in this case what is going to happen? Electronegativity increases, right? So that's why here this will be very electronegative, this will be highly electropositive. In this case it will be less, in this case it will be even less, in this case it will be minimum. It will be minimum, right? So what will happen, because fluorine has maximum electronegativity, right? That is the reason it will, so it's like this kind of situation. This is HF, the electrons are over here. Fluorine is so electronegative, right? If you consider the bond of H and O, right? It's still somewhat here. It's still somewhat here, right? Why? Because this is less electronegative as compared to fluorine. So fluorine is taking out, it actually the shared pair of electron is more towards fluorine because it is more electronegative. So this way hydrogen will be like, he is anyway not giving me the electrons. Just imagine you have a big pizza, right? And your friend is eating all the slices of that, right? You'll be like, I'll go only. Anyway, this guy is not going to give me any, not even a single slice of pizza, right? So you will go, you will eat something else, right? right? Similarly, this hydrogen is in the same situation here, right? Okay. Understood, everybody? Do let me know in the chat box if that is clear or not, right? Okay, so here it was this and here it is going to be, answer is, right, HF, then H2O, NH3 and then you have CH4. That is the correct answer here, right? Yes, everybody, do let me know if that is clear to all of you or not. HF, H2O, NH3 and then CH4. Very good, Guru Raj. That is absolutely the correct answer. Okay. Yes. Okay. Now, let's move ahead. Now, these kind of questions is what you see maximum and they are very easy to do. This we have done in inductive effect as well, right? Now, if you see these here, in these kind of questions, right? Bag bonding is not applied, aromatic is not applied, resonance is not applied, hyperconjugation is not applied. Here, based on inductive effect, you answer this, right? So, how you answer this based on inductive effect? Here you have 3 chlorine, that means 3 minus I group, right? Here you have 2 chlorine, that means 2 minus I group. Here you have 1 chlorine, that means you have 1 minus I group. Now, I told you that whenever you have a carbon ion, right, and you are taking away the electron from carbon ion, it's like stress. When you're taking away stress, it feels happy. So, when you're donating the electrons, when you're giving the electrons, when you're giving the stress to someone, they will become unstable. So now here what you are doing, you are taking away the electrons. That means minus I effect is a friend, right? He is not an enemy, he is a friend now, right? So minus I effect is a friend. So more the number of friends you have, more stable you will be. Here you have 3 friends, here you have 2 friends, here you have 1 friend. So that means A, then B, then C is the correct answer here. Tell me. Is that clear to everybody? A, B and then C is the correct answer here. Is that clear, everybody here? Everybody here? Done? Now, let's see these 2 things. Now, try to answer what you think will be the correct answer. Now, this is a very important thing because usually what we think that this is CH3COO, ma'am. CH3, ma'am, CH3, ma'am, this is a carbon ion. Now, this will show resonance like this. It will be CH3, CO negative, and this is O. This is given in your NCERT. Okay, this is a paragraph in your NCERT in alcohol, phenols, and ethers. So, how I am teaching you is not like again when we will do the chapters again, I'll teach you acidic strength of phenols, alcohols. No, right? I'll tell you the order. Yes, that I'll tell you, right, when we'll study alcohol, phenols. But all the things related to acidic strength that are in different chapters we'll discuss here only, right? Okay, in between little bit we'll discuss, but more maximum I'll discuss here only, right? So, these are the 2 resonating structures. Now, let's see if you talk about when phenol, right, it loses a hydrogen, this is a carbocation that is formed, right? Now, ma'am, this also shows a great amount of resonance, right? This also, if you see, it shows a great amount of resonance, negative here, this is double bond O, then again this bond will shift here, this bond will shift here, and this beautiful resonance is shown by this phenoxide ion, isn't it? This very amazing resonance is shown by this bond will shift here, this will shift here as negative, this will be double bond O, then this negative will shift here, this will shift here, and you will have 5 resonating structures just like you had for phenols. Here you will have 5 resonating structures here, right, as well. So, if you remember, we have studied that more the number of resonating structures, more will be the stability, right? So according to that logic, right, this should be more stable. This carbon ion, phenoxide ion should be more stable as compared to this carboxylic ion, carboxylate, right? But in reality, this is not the case. Why even after having 5 resonating structures, this with 2 resonating structures is more stable. Why this ion is more stable? Reason is it is giving rise to equivalent resonating structures. And equivalent resonating structures, this is written in your NCERT, right? That's why this is a very important line. Equivalent resonating structure are always, even if it is 2, it is more stable as compared to 5 resonating structures of phenol or phenoxide, right? That is the reason E is more acidic as compared to B. Acetic acid is more acidic as compared to phenol. Okay, acetic acid is more acidic as compared to phenol. Very important, right? Okay. Now let's look for this one. Let's see this one. Okay, some general things that they can ask you. Yes, right? No, acetic acid is stronger as compared to phenol, right? Okay. The energy of resonating canonical structure is almost yes. But hybrid has less energy, right? Hybrid resonance, hybrid has less energy. Okay, now tell me this thing. You have this negative, you have this. Out of these, which is more stable? This is A and this is B. Now guys, if you see this here, right? Again think about Barhi. You have to tell the acidic strength based on this, right? I'll tell you how exactly. See, this will have a hydrogen, this will have a hydrogen here, right? Now, because they have given you this compound, now you will think that, ma'am, where should I tell, where is this hydrogen which it needs to lose? So, which is the most acidic hydrogen? This will be the most acidic hydrogen that is not visible to you. Now here if you see, you will see that Barhi back bonding is applied here. Because sulfur has vacant d orbitals, right? Now after losing this proton, right, I'll just copy this, right? After losing this particular proton, it will have a negative here, it will have a negative here, right? Now is back bonding visible to you? Though this sulfur has lone pair of electron, but because this is carbon ion, it is looking for an electron deficient thing. And which is electron deficient? Sulfur has vacant d orbitals. So sulfur is going to show a very good back bonding, and that is the reason E is more acidic as compared to B. So you can say A is more acidic as compared to B. Understood everybody? Yes, if they have given you this directly, that means they are talking about carbon ion. But if this is given to you, then it's tough to understand that this hydrogen that we have to remove, and after that we'll have a carbon ion, right? That carbon ion stability will tell us which acid is more acidic. So this will be more acidic as compared to this one. Okay. Now let's see next question here. Now this one is also very interesting. Okay. This one is also very, very interesting. Okay, so you have HA here, this is HB, this is HC, right? I think this is from MS Chauhan, if I am not wrong, right? So this is, I think, from MS Chauhan, right? And very interesting questions you have there. So I picked up like questions from those books, right? So let's see what we are going to do. Now they are asking you, out of HA, HB and HC, which will be more acidic? This you have to tell, right? These kind of questions easily can be asked in JEE Mains and JEE Advanced as well, right? So you need to see this carefully. Now I have to remove this and this one by one. Then I'll see which is making more resonating structure. Based on that, I'll tell the acidity. Okay? 3 H are given to you. I'll remove one by one each of them. Okay? So I'll show you how. Firstly, let's see, you have remove HA. Now when you remove HA from here, what you will have? You will have the formation of, this is double bond O, right? This will be O negative, right? And this will be OHB. Anything else you will not remove. Okay? This will be the case. Now I am just ignoring HB for now, right? Because otherwise I'll have to draw it again and again, right? So just remove HA and this will be the structure that you will have. Now you need to see whether this structure is forming any resonating structures or not. Try to draw it. This is negative single bond double bond. This is negative single bond double bond. That means that way it is not forming any resonating structure. This way it will form, double bond will shift here, it will shift here, and you will have a resonating structure that will be, this is double bond O, this is double bond O, and this is OH, this is negative, this is OH, right? So can I say that in this case, this is showing two resonating structures. In these two structures it is existing, right? So if I say this is first, then this is the second one, right? So two resonating structures it is showing in which it is existing, right? Just remember, more the number of resonating structures, more will be the stability of that carbon ion. That means losing that H will be better. So if it lose HA, it will have two resonating structures, okay? Now let's see, let's remove HB. Let's remove HB here. Now see guys, if I remove HB, what I am going to have, right? If I remove HB, so here this double bond will be as it is, right? This OH will be as it is, this double bond will be as it is, this will be O negative because HB I have removed, and here this will be OH, right? Okay, see everybody? Yes. Now see this thing, is it showing any kind of resonance? Double bond, single bond, okay, this is negative single bond, double bond, right? Yes, it is showing resonance, right? Let's see this. This will shift here, this will shift here. So it is definitely showing a very beautiful resonance if you see, right? So this is double bond O, this is OH. Here you will have one negative and here you will have double bond O, right? Because this oxygen, this negative has shifted here. This will be OH. Now, is it still showing any resonance? Yes. Negative single bond, double bond. So, this will shift here, this will shift here. And they are shifting negative charge on oxygen. Even better, an electronegative atom has negative charge. What can be better than that? Isn't it? So here I'll have O negative, here I'll have OH, here I'll have double bond O, this will be OH. Now can I see how many structures you have drawn here? How many resonating structures? This is 1, this is 2 and this one is 3rd. So definitely more resonating structures. That means losing HB, you can have 3 resonating structures. So it will be like I want to go, because if I leave, then I'll have more resonating structure which will give me stability, right? Then students, you have HC. Now let's remove HC. Now let's remove HC here, right? HC means this one you have to remove. Okay, try to draw it yourself. This will be as it is, try to draw it yourself, double bond as it is. This will be OH. I'm not writing A or B, right? Essay, I'll like, more waste of time will be there. This is OH and this will be O. That's it, negative. Tell me, any resonance is it showing? Let me see if you can answer that or not. Is there any resonance here? Is there any resonance here or not? Any resonance here or not? Tell me, in this structure, can you see any resonance or not? Yes, Varna? Yes. Okay, tautomers, beta, let's not get into that. It has a different conditions, right? We'll talk about that. We'll talk about that. With these structures only, we'll talk about that. That's a very good point that you have pointed it out, but we'll talk about it in the isomerism. Okay, so it does not have, how difficult it is to say no, right? No, double bond, this is negative single bond, single bond. So there is no resonance with this negative. Now you will say, ma'am, resonance is there, ma'am, this resonance, ma'am. With this negative, you don't have any resonance. Even if resonance it is showing here, even if it shows resonance here, it is shifted negative, even then there is no resonance of this O negative. So that means I can say this particular O negative is not under resonance, so this will be least stable. Now if you see, it is giving you no resonating structure, it is giving you maximum. If you are also ignore this one, this is giving you HB is giving you maximum resonating structure, so answer will be HB. Then you had HA, last one was HC, so answer is HB, HA and SC. This is the acidic strength. As acidic strength, you can say HB would want to, like, firstly HB will lose, then you will have HA, then you will have HC. Reason being, because after losing this, you will have a very stable carbon ion, after that HA and after that HC. Right? Okay. Yes, everybody. Now, let's move next. Right? Okay. HB, A and C. Now, see this here. See this here. Now, in these kind of questions, usually they don't give you like this. Okay. They will not give you like this. Rather, they will give you the question like this. Okay. Rather, they will give you the question like this. Like this. Like this. And they will ask you which will be most acidic. Now, you have to find out the most acidic hydrogen. Right. That will be definitely over here, which is like which wants to go. Right. So, we will check on this hydrogen here. Right. So, this is the hydrogen, this is the hydrogen, this is the hydrogen that we want to check whether it wants to, whether it will lose or not. So, when you lose this hydrogen or this hydrogen or this hydrogen, you will have this negative, negative, negative over here. Right. Now, if you see, apply Barhi here, apply Barhi here. So, first is back bonding. So, if you see back bonding here, this is vacant, sulfur is vacant. I'll again write sulfur has vacant d orbitals, vacant d orbitals, and that is the reason. Here it can show back bonding from two sides. Here it can show back bonding only through one. Here there is no back bonding because oxygen does not have any vacant orbitals. So, it will have no back bonding. No back bonding, and that is the reason that here you will have A is greater than B and then C. So, answer will be ABC is the correct answer here. Yes, everybody, let me know in the chat box if that is clear to all of you or not. If this particular part is clear to all of you, do let me know, and I can guarantee that apart from this, you will not have any other thing, right? They will only, make a new question out of the questions that I am teaching you, right? Okay, that's my promise to you. Okay, everybody, right? So, answer will be A, B, C because here back bonding is maximum. That makes this particular carbon ion most stable, and that is the reason if you see the acidic strength here, A will be more than B than C, because carbon ion is stable maximum for A, right? And that's how you will have this answer, right? Okay. Now, we'll see, this is also actually in MS Chauhan, right? So from there only you will see that this kind of thing, this is though in your NCERT also, this you have in your NCERT also. So there is a question that is based on equilibrium and acidity, right? You have to tell based on acidity whether that reaction will be forward or backward, right? I'll show you the kind of question that you have, okay? For that you need to know the order, right? Okay, everybody? So let me just see. Okay. So if you see this here, right, you need to tell whether this reaction will be forward or backward. So is this a question of equilibrium? No. This is a question of acidic strength. So always reaction will move in that direction. Write it here. Reaction will always move from strong acid to weak acid, okay? Strong to weak acid. Reaction will always go in a direction from strong acid to weak acid, right? Let's see how. So here you have CH3COH and here you have H2O. If you see this here, CH3COH is a stronger acid as compared to H2O, right? So if it is a stronger acid, you can just write here it is a strong acid. This is a weak acid. Water is a weak acid as compared to that. So here what will happen, right? From strong acid to weak acid it will go. That means the reaction will be forward. Now that is a thing that you need to learn. Now I'll tell you what is the reason why I have given you this thing ki it is from strong acid to weak acid. Why do you need to cram it? Okay, let's understand it. Because see, if it is a strong acid, it would want to lose H positive, right? If it is a weak acid, it will be a strong base. We know, if it is a weak acid, it will be a strong base, right? That means it would want to accept the H positive here, right? So that is the reason if it is a strong acid, it will easily lose. That's why it is moving forward, right? Now next is this question. Next question is you have alkyne and water, right? So when you see this, water is a strong acid as compared to alkyne. This is a strong acid as compared to alkyne. This is a weak acid, right? This will study in like throughout the organic chemistry. Will learn acidic strength of different things, right? So in that way also you will learn that why this is more acidic, why this is a weak acid, and how come alkyne is acidic, because this hydrogen is very acidic, but as compared to water it is a weak acid. Okay, that we'll study when we will study hydrocarbons, right? So here always it moves from strong to weak. That is why the reaction is going to be backward, right? That is why the reaction is going to be backward, and hence this is the answer, right? Okay. Yes, everybody. Water is neutral. Yeah, is it? So it's like water, if you see this here, it has acidic nature. It has acidic nature. That's why we are comparing this with this alkyne, right? That's why even in here we have, don't think about neutrality that ma'am, yes, its pH is this and that. That is there, but now we are thinking that will it be able to lose H positive if it is put under certain conditions? Yes, it will, right? It will behave as an acid depending upon which you are comparing it with, right? Okay. Yes, everybody. Let me know in the chat box if that is clear to all of you or not. Because now we are going to start with carboxylic acid, phenols, all these things. Right? Okay. Thank you, Renix. So, yes, everybody. Yes, everybody. Right? Okay. Swarna is saying, ma'am, teach any advanced question. For that, I'll be taking extra session for you. Otherwise, all the questions that I'm teaching you, your JEE mains and advanced, everything will be covered, right? But for that, firstly, you need to know the core of acidic strength, right? I can't just throw questions at you, right? And after this, after completing isomerism, I'm going to take a specific lecture on top questions from JEE mains and advanced for GOC and isomerism. There we'll see more high level, but that you will only be able to understand if this thing is clear. Then you'll be like, ma'am, I didn't understand, ma'am, please explain again, ma'am, please explain. Why? Because core is not clear, right? So let's focus on basic first, right? The foundation has to be very strong. Only then a big building can stand on it. Otherwise, it will collapse, right? So, let's see rules of acidic strength. Ready, everybody? Okay. Yes, ask it, Pranav. Yes. Meta effect does not operate. So, one by one, we'll see the rules. Meta effect does not operate on meta effect, I am saying. Mesomeric effect. It should be mesomeric. By mistake, I have written meta here. It should be mesomeric effect does not operate on meta position. At meta position, mesomeric effect will not operate, right? What is the reason? If you see the structures, if you have a group, even if it is showing minus M or plus M, right? Let's say it is showing minus M. Then you will have positive charge here, positive charge here, positive charge here. On meta, right, nothing as such is happening, right? And if you see a group that is showing plus M, right? It will have negative here, negative here, negative here. That means on meta, there is no change here that you are doing, right? The change is on ortho and para position. That's why meta effect, that is why mesomeric effect is not obeyed on the meta positions, right? We'll see how it affects our acidic strength here. If you see these two compounds, right? Let's see from this position, we will talk about the mesomeric effect, right? If you see here, in this case, on the para position, see, NO2 shows two effects. NO2 shows minus I also, minus M also, right? So here both will be obeyed, minus I, minus M. Here minus I, minus M, both will be obeyed, right? Here also minus I, minus M, both will be obeyed, right? In this case, at para position, minus I, minus M, both will be obeyed. At meta position, because mesomeric effect is not valid only, so here only minus I will be obeyed. Here only minus I will be obeyed. Because it is not valid, right? Okay? It is not valid. And that is the reason, if you see, overall, electron withdrawing effect is more in this case. Moreover, here minus I group is near here, right? So that will also dominate. So all the factors, right, are telling us that A will be more stable as compared to B, because when you talk about a carbon ion, it is, if you have a carbon ion, right, if you give the electrons, it will become unstable. If you take away the electrons, it will become stable. What I told you, it's like stress. When you take away stress from someone, they become very happy, they become stable. Okay, that's how you're going to understand this, right? Okay. Now, next, why I did it? Okay. Okay, Now let's talk about ortho, and this is a very important part of today's lecture, that is ortho effect. Mark it like very important, right? If ortho effect is not clear to you, right, then you will do a lot of mistakes, right? But if ortho effect is clear to you, trust me, this acidic strength will be a very simple game for you, right? But the condition is ortho effect, the exceptions, everything should get into your head. If this is there, it is clear which group will show, which will not show, everything, then you are not going to fail in acidic strength, that I can guarantee, right? So full focus here, it's a very important topic, right? So let's see, let's understand that. Firstly, what I'll do, yes. Firstly, let's see what exactly is happening. What exactly is happening here? Firstly, I'll just remove this, right? Firstly, we'll see what exactly is happening when you have, and this effect is valid on benzoic acid. So I'll draw benzoic acid here. So what you have here, this is benzoic acid, 1, 2, 3. This is C double bond O, and this is OH, right? Okay, this is benzoic acid. Yes, everybody. Now if you see benzoic acid, all of it is in the same plane. So for plane, what I'll do, I'll just draw it here, that all of this is in the same plane. Okay, this is in the same plane. This is a plane that we are talking about, and this is in that same plane. Okay, this is in one plane. Because the plane is same here, right? Because the plane is same, so there is no tension on that, right? Plane is same here of COH, right? Now this benzene and this COH is on the same plane, right? Now what we will do, if you attach a group here, if you attach a group here, right? This is C double bond O, OH. If you attach, understand this very carefully, if you attach a group here, what is going to happen, right? If you attach a group here, guys, what is going to happen? Let's understand that. Okay. Organic chemistry from you. Yes, Arav, we will do that. Definitely we will do that. I'll do everything. Okay, don't worry about that. Don't worry. I'm here only, going nowhere, right? So this is the group, this is COH. Now see what will happen. Earlier it was in the same plane. Now see this, very important. Now what will happen? This plane is going to change. I'll tell you how. This is a very big group. Okay. This is a very big group. This group will create steric repulsions here, right? This is also a very big group. So what will happen here? They will create repulsions with each other, right? That will create repulsions. So now what will happen? Because of the repulsions, now what will happen? Because of these repulsions here, right, the plane will be changed, right? The plane will be changed. I don't know every class why this have to fall. Why it has to fall in every class, right? So here what will happen? The plane will change. I'll just show you how the plane is going to change, right? So I'll delete it only, right? I'll just erase it. Now let's see how the plane is going to change, right? This was your benzene ring, right? Now what was happening? This is C, this is group G. Now because of these steric repulsions here, this particular group that was like this, now it will shift to the plane and it will move, right? Because repulsions will be there. So the plane of the COH will be changed. That means if it earlier it was upwards, now it will be downwards here, right? if here earlier it was upwards and then downwards, now it will be O then H. If you see, I have changed the plane. This was up, then this. It was like this, right? Now it is like this. Okay? So I have changed the plane here, right? Now this plane change, right? You can also show it like this. You can also show it like this, that what exactly will happen? What exactly will happen? You will have, this is your, let's say this is your one plane. This will be in some other plane, right? This will be in some other plane, right? And this whole group will be in some other plane. This will be in some other plane. Firstly, tell me, is the plane concept clear to you? Why ortho effect is existing? Because of the shifting of this plane here. Tell me, because the plane is switched here. Tell me everybody if that is clear. Irrespective of group, yes, ortho effect will be obeyed irrespective of the group, right? Now see, because of this, what will change? Right, now see, plane change, you get it now. Now see what it will change. I'll tell you why plane changing, ma'am, but why is it giving ortho effect? Let's understand that, right? So what is happening here? Here we know that when it loses H positive, right? When it loses H positive, there will be this negative here. It will jump here. It will jump here. This resonance it can show, or it will jump here. Or it can also show this kind of resonance. This is single bond. This is, not this one. Wait a minute. Yes, okay. So here it is getting removed, right? This is negative single bond, double bond, this resonance. And here it can also show negative single bond, double bond. So it can also show this kind of resonance. Benzene, single bond, double bond, right? Because it is in the same plane. So this resonance also it can show, isn't it? This resonance also it can show. I'll just show it with some other pen, right? This resonance also it can show. This resonance also. Two resonances are possible here, right? Two things are possible here, right? Now if you see, if the plane has changed, now this is a different plane, this is a different plane, right? Now when it loses H positive from here, it will be negative, and that's why it will show only this resonance, because this benzene and this is in a different plane. It's like this, right? Earlier it was in the same plane. That's why full resonance was there. Now it is in a different plane. So that's why the resonance is not possible in this case. So here it is only one resonance, that is complete resonance that it can show, right? And that will be an equivalent resonance that it will be showing. And that is the reason, because it is showing you an equivalent resonance here. That is the reason there is no some other resonance, there is no cross conjugation that is happening here, right? That is the reason this particular, when you have a group here, this anion will be more stable, and that is the reason when you have ortho group, when you have group at ortho position, any group at ortho position, any group at ortho position is going to increase the acidic strength. Acidic strength of benzoic acid. Of benzoic acid, okay, of benzoic acid. That's how it is going to increase the acidic strength of benzoic acid, okay, yes. So now if you see this here, that is done, this is okay, this is okay. Now we are going to see the, like, what are the groups that actually shows this particular acidic strength here. So the groups, if you see, this group, if you see, has to be bulky, right? So if you have COH here, firstly it is shown only by benzoic acid, then this group has to be bulky. The first thing is, you should have benzoic acid. You can't apply ortho effect in OH, Phenol you can't apply. This will be applied in benzoic acid. So it will be shown by benzoic acid. Second thing is any group which is bulky, any group which is actually bulky and actually creating any repulsions. Now, if you have group like hydrogen, deuterium, tritium, OH, NH2, CN, they are going to have no effect on the ortho position, right? So, if you have NO2, any alkyl chain, CHO, any halogen, that is going to show ortho effect, right? Okay, everybody? Yes, everybody? Is that clear? Yes, everybody? So what we have, only these groups are going to show because these are bulky groups, these are heavy groups. Heavy groups only can show repulsion here. If the group is not heavy, it will not create any repulsion. If there is no repulsion, there will be no ortho effect. So you can't apply it everywhere. Though they will give you only these groups, but if you see this group, right, then don't apply ortho effect there. It will not be valid. Okay? Now, second factor is effect of hydrogen bonding, right? Second factor is effect of hydrogen bonding, right? Okay, everybody, let's see this. Now, when we talk about hydrogen bonding, right, in that case, let's see how it can increase also or decrease also the acidity. So, it can also increase the acidity, it can also decrease the acidity, right? So, let's talk about the first thing here, that is, let's talk about benzoic acid, which has, now tell me, will ortho effect be applied here or not? Let's see. Will ortho effect be applied here or not? These kind of, you were asking about JEE Advanced question, na? This is important in JEE Advanced. Sometimes those students who don't have enough knowledge about, they just know, okay, on ortho group, any group is there, it will show ortho effect. No, it's not like ortho effect will be shown by any group. If you have OH, NH2, Cl, they will not show any ortho effect, right? They are not going to show this effect, right? So here, first thing to remember is there is no ortho effect here. No ortho effect here. No ortho effect here. But one thing, if I see this, out of OH and COH, which has more acidic strength, definitely COH, because it will form equivalent structures, right? So that's why when you see, when it loses H positive, it will lose H positive from this one, and you will have the formation of, this is the benzene, this is the benzene, and this will be C double bond O, O negative, and this is OH. Now, can you see, after removing the H positive, you have the formation of very good hydrogen bonding. So this is intra-hydrogen bond. Intra-hydrogen bond. That means after losing this H positive, you have the formation of intra-hydrogen bonding, right? That means this would want to get loose, okay, because the carbon ion is getting stable because of hydrogen bonding. So here, when you have hydrogen bonding, it increases the acidic strength. It increases the acidic strength. Okay, it is going to increase the acidic strength here, right? Now let's talk about, if you have this at para position and ortho position. This is the ortho position. Let's talk about this same thing on the para position. If you have OH on the para position, see, on the para position, if it loses H positive, it is not going to show any hydrogen bonding. No intra-hydrogen bonding is there, right? No intra-hydrogen bonding is there. So if this is your para and this is ortho and this is ortho, out of this, if you talk about acidic strength, which will have more acidic strength? Which will have more acidic strength? Ortho is going to have more acidic strength. Ortho is going to have more acidic strength because after losing H positive, it is forming intra-hydrogen bonding, and this after losing H positive is not forming intra-hydrogen bonding. So ortho is going to have more acidic strength as compared to para, right? Okay, so here it has increased, right everybody? Now let's talk about ortho nitrophenol and para nitrophenol, right? If you see this here, this is ortho nitrophenol. So you will have this thing here, this will be OH, this will be NO2 here, right? This is a actually very famous question, but the problem is students think that always in the case of hydrogen bonding it will increase or decrease. No, right? It depends. Right? So that's why these two comparison questions you have. Now see this thing, if it loses H positive, if I say if it loses H positive, right? If it is losing H positive, if it loses H positive, it will become O negative. If it loses H positive, it will become O negative, right? Can you see nowhere they are showing hydrogen bonding, because hydrogen you have lost, so hydrogen bonding will not be there. That means here after losing no hydrogen bonding is there, but without losing it is making intra-hydrogen bonding here. Here you have no hydrogen, this is having intra-H bond, and this has no intra-H bond. This will have inter-hydrogen bonding, because this has intra-H bond, so this hydrogen here is not free to lose. If you lose this hydrogen, the hydrogen bonding, that is intra-hydrogen bonding, because of this intra-hydrogen bonding, this hydrogen is not capable of getting loose, right? And that is the reason here if you see, this is ortho and this is para, this is ortho and this is para, then the answer is going to be, answer is acidic strength of which will be more? Acidity of ortho is more than para. Wait a minute. No, para is more. Para is more than ortho, right? Because this hydrogen is not ready, right? This hydrogen is like, yes, I can go because I am not under any intra-hydrogen bonding. So because of intra-hydrogen bonding, this hydrogen is not free, right? Okay. Yes, everybody. Yes, everybody. Tell me, is that clear? Again, the time is something else only it is showing. Yes, everybody. Rama Raju, Abhishek, Pandit G. Okay. Yes. Understood? Okay, here ortho was more stable, here para is more stable. Please see this concept and then only, just don't say that okay, hydrogen bonding ortho is more. See if after losing it is beneficial or without losing it is beneficial, right? So according to that the answer will be. Now guys, see this, let's talk about these effects here, right? The conclusion part I have already told you, but now some specific things that you need to know, right? Now guys, always remember, right, these are, see if let's say for example you have NO2. For example, you have NO2. NO2 is showing minus M and minus I both. So it doesn't matter which is dominating, right? So you can take a chill pill there, right? Because both are electron withdrawing only. But when you have the set like, when you have plus M minus I, minus M plus I, then you need to think which one is more dominating, right? So in usual cases, mesomeric effect is more dominating as compared to inductive effect, right? So here we can say that mesomeric plus, these are showing plus M and minus I both, but here plus M effect is more dominating as compared to minus I, right? In halogens, minus I is more, this is very important, this is very, very important. In halogens, minus I is more dominating as compared to plus M, right? But the overall, now if I say minus I is more dominating, that is the reason it is deactivating, right? And it is ortho-para directing because of this plus M, right? But understand one thing, then if I ask you, ma'am, then minus I is dominating, that means electron withdrawing power will be according to minus I. Then according to minus I, fluorine is most electronegative, then chlorine, then bromine, then iodine. This should be electron withdrawing power, and this is the biggest mistake that students do, right? This is the biggest mistake that students do. This is not the electron withdrawing order, right? Electron withdrawing overall effect because of this minus I, and because plus M is not dominating, but it will play some role there, right? Because of the plus M effect here, what will happen overall will be fluorine, then chlorine, then bromine, then iodine is the most electron withdrawing, right? That is very, very important, right? Because based on this, easily students can make mistakes, right? This you have to remember, right? Okay, guys, please focus here, right? You're only disrespecting me for by looking at other chats and not focusing, right? It is wastage of my energy also, right? Okay. I don't want to tell you every day, but today also I had fever. If you see I'm speaking very slowly because my throat is not well, right? So even then if I am standing here, so please appreciate that and please focus on the studies, okay? So don't like waste my energy or your energy and time, because for me next batch will come and it will fade away. But for you, next year will not come, right? For you, this is the day, this is the month, and this is the year that you need to work hard, because I have done what I have done already, right? By teaching you more or less, I am not going to change my future. I can only change your future now, right? So your future, you have not built it now. Your future is in your hand, right? So no benefit I'll get if you study more or study less. I am teaching here, right? I am doing my duty. If you study more, you focus more, right? You don't get distracted. You will get benefited out of that. For me, everything will remain the same. For you, things will change. Okay, so understand that it's your benefit, it's not my benefit, right? Okay, yes. Now let's see this here. Let's see this here. Okay, wait a minute. Yes, everybody. Now, if you have CCM3, we know that it shows hyperconjugation also, it shows minus I also. So here, even though in case of Barhi, hyperconjugation is more dominating, but in this case, inductive is more dominating. So mark it important. Then in case of CO, if you talk about, these are the exceptions that we are talking about. In case of Barhi, mesomeric, that means resonance is more dominating as compared to inductive. But in case of COO negative, inductive plus I factor is more dominating as compared to minus I. These are the exceptions that you need to learn before going further, right? Okay, yes. Done. Now, next is plus M. That means plus M effect due to lone pair. Let's say you have due to lone pair like this. You are showing plus M due to this lone pair, right? Okay, due to this lone pair you are showing plus M effect. That is more dominating as compared to plus M due to delocalized lone pair. Now can you tell me what is a delocalized lone pair? Let's say you have OCOCH3. Now this particular lone pair is also delocalized here, right? So it is also delocalized here. So that's why because of this cross conjugation, it will be less, it will show less effect, right? It will show that this is what we have learned here. If you remember, this is what I told you here. This was plus M effect due to delocalized, and this was plus M effect without any delocalization, right? Okay, that means there was no cross conjugation here, right? Okay, everybody, tell me, is that clear? Now let's move and focus on the questions of questions of acidic strength. Let's start doing it. Let's start doing it. Let's see. Now it's all about questions, questions and questions, right, for next 1 hour. So everybody focus here completely, right? Okay. Yes, everybody, let's wait a minute. Wait a minute. Wait a minute. Okay. Just okay. Yes, everybody, let's see. This is A, B and C, right? So you need to tell me what is the effect that it is showing. A, B, C, right? So if you see this here, right, this is showing no effect. This CH3 and OCH3, what is the effect that it will show? Yes, everybody? Yes, everybody? Everyone in the chat box, everyone in the chat box. Thank you, thank you. So if you see, this CH3 can show you plus M also. It can show you plus I also. Both the effects it shows, right? Either ways it is donating only. This can show minus I also, and this also shows plus M. But plus M is more dominating here, right? Here you have plus M, here you have two effects that are donating. Here you have one effect that is donating, other is withdrawing. That means overall here donation will be more, right? Here overall donation will be more. So we can say here the no effect is there, that means it will be most stable, right? Then here you are giving the electrons, you are making it very unstable, right? Here you are giving the electrons, right, by plus M effect, right, even less, right? If you talk about Barhi here, if you talk about BARHI, right, mesomeric effect is most strong here. So here mesomeric effect is dominating. That is why with mesomeric, when you are donating the electrons, it will be maximum donation, right? That is why it is having minimum stability. In this case, you are donating by plus H and plus I, right? So that is why here hyperconjugation is more dominating, and that is the reason hyperconjugation and mesomeric has more strength. That is why here donation will be more as compared to this one. So answer will be A, B, C is the correct answer. Okay? Yes, everybody? Is that clear? Is that clear? Now, next is you have, this is A, B and C. Okay? Or you know what I'll do? I'll write A, B and C here, because here I'm going to write the effects. Right? So tell me one thing, what are the effects that it can show? So I have already told you this will be minus I and this will be minus M, right? And here it will be minus H and this will be minus I, right? And here it will be minus I and plus M, right? Okay? And on the para position, all the effects are valid, right? Yes, everybody? Yes. Now tell me which one will be greater wear, right? In this, I told you in case of halogen, mesomeric is less and inductive is more. This also in the exception case, I told you that in this case, minus I is more valid, right? In this case, minus M is more valid. That means here, this is dominating, here, this is dominating, here, this is dominating, right? Now, if you see this here, because of minus M, if you talk about Barhi, B-A-R-H-I, right? Then mesomeric effect, resonance and mesomeric is same only, right? If you talk about this effect here, because of this mesomeric, or you can say resonance, right? This effect is R, right? Because of, or you know, instead of writing Barhi, you can also write Bamhi, right? Whatever you write. Okay, so I am used to of writing Barhi, then you should remember that resonance and mesomeric is same only, right? So mesomeric effect is most dominating, so it will pull out the electron here with maximum strength. Then out of these two you have inductive, and here you have this wait a minute, yes, minus I it is showing now. So if you talk about here, you will have negative. From negative, when you take out the electron, that is a very good thing. That means this will be maximum acidity. Out of this and this, if you see, overall effect we have to see, right? This is minus H and minus I, right? This is actually minus I, and here you are donating also by minus plus M. So if you see this here, minus I effect is same for both of them, right? But if you see this here, this is also donating by plus M. That means it is making it less stable, right? By donation, you are making it less stable. Just remember that acidity is directly proportional to electron withdrawing and inversely to electron donating group. So when you have donation, it makes it less stable, because minus I was same in both the cases, right? Okay, and moreover here you have 3 chlorine. So here minus I of CCl3 will be more than Cl. Minus I effect of CCl3 will be more than Cl, so it is going to pull out the electron with more strength. So withdrawal of electron will be more, so this will be more acidic in nature, right? Then the third one is, you have, this is A and this is B. Now this is the meta position. Now I told you the first rule that at meta position mesomeric effect is not applied. Okay, so what are the effects? Here mesomeric effect is not applied, so this will be minus I only. Mesomeric and hyperconjugation is same thing only, so because that is delocalization, that is not applied, so this will be minus I. Now you need to tell me which one will have good minus I effect. Which one will have good minus I effect? For this you need to watch inductive effect lecture, where we have studied about inductive effect, that the inductive effect of this NO2 group is stronger as compared to CCl3 group, and that is the reason it will be more acidic. So answer is, this A is more acidic as compared to B, right? Okay, next question here. This is A, this is B, and this is C. Now a very famous question this is, right? So NO2 group at different positions you have, right everybody? NO2 group at different positions you have. So let's see what you are going to do. At para position you will have minus I and minus M also. So no, it is minus I and minus M, yes. Obviously minus M will be more dominating, but both are withdrawing only, right? So here also you have minus I and minus M. But in this case at meta position, because at meta position mesomeric effect is not applied only, that is why this will have minus I effect only, right? That is why it will have only minus I effect. Now see one thing, if here you have minus I minus M, mesomeric effect is same, NO2 is going to show the same mesomeric effect because the group is same, right? That means firstly this is different. This is only showing the inductive effect. These are showing two electron withdrawing effects. So that means here electron withdrawing effect is less. If the electron withdrawing effect is less, right, it will make it, right, more stable, right? So here this will be more stable, right? No, actually no. Wait a minute, what I have written there? Electron withdrawing na, I have written opposite. More the electron withdrawing na, here it will be less, yes. So here less electron withdrawing group means less pulling of electron towards itself. That means the carbon ion is not getting stable, right? So here it will be least. Out of A and B, if I have to choose, right? Because mesomeric effect is same in both the cases, so I'll choose from inductive effect, because inductive effect is distance oriented, right? So because of this distance orientation, this will show more minus I effect as compared to this one, right? Okay, this will show you more minus I effect as compared to this one, right? So here it should be B then AC, right? B then AC. Wait a minute. More minus I, if you have there, more minus I, here minus I is going to make it unstable, no? Minus I is going to make it, wait a minute, just give me a second. Minus I is going to make it stable, right? So here distance is less, so minus I will be more. Here distance is more, so minus I effect will be less, right? So it should be B, then you have A, then you have C. Right, everybody? Okay. Yes? Yes, everybody? Okay. Oh, I forgot about one thing only. I'm so sorry, I'm so sorry, I'm so sorry, I'm so sorry. We forgot about one thing here, right? That here it was showing us hydrogen bonding as well. We forgot about that effect. Hydrogen bond. So if there is hydrogen bond here, then things will be different. Now things are different. Now things are different. C is least stable, that we know. But because here this hydrogen is not free, so even after, because even it has more minus I, even then because of this hydrogen bonding, this will become less acidic because hydrogen is not free here. So this will be B and this will be A. So answer is going to be A, B, C is the correct answer here. Okay? Yes, everybody? Yes. Intra-hydrogen bonding will make this less stable, less acidic, right? Okay? Now, next thing is, here you have, this is A, this is B and this is C. Now in these cases, you have to find out the effects here, right? So if you see this here, it will be minus I minus M. Here also it will be minus I minus M, right? Here also it will be minus I minus M. Here also it is minus I minus M. Here also it is minus I minus M, right? Now can you see one thing? Can you see? See, intramolecular hydrogen bonding, right, is there. Here you have two intramolecular hydrogen bondings are possible, right? Moreover, you have this thing, right? But here what is happening here, because of 3NO2 group here, 3NO2 group here, this is so electron withdrawing, this is also electron withdrawing, this is also so electron withdrawing, that this will become the most acidic here, picric acid, right? Here you have less NO2, so it will be less. Here you have only one NO2, it will be even less, right? And that is the reason here the order will be CBA, because of the more the number of NO2, more will be the electron withdrawing nature, right? Okay. Now, let's see this one. Here you have, this is A, B, C and D. Let's talk about this one. Yes. Let's talk about this one, everybody. Now, do you remember the electron withdrawing effect? Electron withdrawing effect will be minus I, iodine, chlorine and then fluorine. It's like this. So this has maximum minus I, right? But we also need to consider plus M here, right? Because minus I plus M both are valid here, right? So here minus I and plus m both. Firstly, I'll just write what is valid here, right? This is minus I plus m both are valid. Here minus I plus m both are valid, right? Here minus I plus m both are valid. Here minus I plus m both are valid. Do you remember when I told you, right, when minus I and plus m both are valid, then the overall effect will be this thing. Then the overall electron withdrawing nature will be this thing, if both are valid. Because minus I is more dominating, but the overall effect it will give it like this. This is a very important question. Usually students do it wrong, right? So overall effect is not based on minus I. It is a mixture of both the effects, that is iodine, then bromine, then chlorine, then fluorine. It has minimum, right? So this has maximum electron withdrawing nature. That is why it will make it the most stable, and answer is going to be DCBA. Okay, answer will be DCBA, right? Okay, now let's see next one. Let's see next one. Here, this is A, B, C, D. Now these two questions are in comparison with each other, because here if you see, on meta position never mesomeric effect is never applied. So here you will have only minus I, only minus I. So when I talk about only minus I effect will be fluorine has maximum electron withdrawing electronegativity, then chlorine, then bromine, and then iodine. Now the order has completely changed, because now mesomeric effect is not valid only, right? If mesomeric effect is not valid, we will not see the overall effect. Their mesomeric effect was also valid because it was para position. That's why I saw the overall experimental electron withdrawing order, right? This order is what you need to remember when both are applied. This is when you have only one thing, right? And that is the reason very good. So here this has maximum electron withdrawing, so answer will be A, B, C, D is the correct answer here. Okay, now let's talk about this one. This is A, this is B, this is C. Let's see if you can answer this or not. Firstly, OCH3 give which effect? OCH3 guys, it will give which effect to you? OC3 will give which effect? This will give you minus I and plus M. At meta only minus I, right? At para minus I and plus M. Now tell me which one is more strong, mesomeric or inductive? This I told you in the starting of this lecture, right? Mesomeric effect is more dominating, right? In this case, mesomeric effect is more dominating. Now, if the mesomeric effect is more dominating, then firstly I'll see because here you don't have any plus M, right? That means no one is giving the electron. If there is electron donation, it will make it unstable. Here you have no effect which is donating the electron, so this will become maximum acidic because no donation is there. In this and this case, donation is there with same extent, so differentiating factor will be minus I. Tell me where you will have more minus I. Yes, students, where you will have more minus I. At ortho position, because it is less distance, so minus I effect will be more here, right? Minus I effect will be more here. So can I say this will be B, A and then C, because here distance is less. distance is less for minus I effect to operate. For minus I, distance is less, here distance is more, so minus I effect will be less here. So it is BAC is the correct answer here. Okay. So you have to see all the factors. Till now we have not started doing ortho effect. That will make it even more confusing to you. Right? Okay. So this is A, this is B, this is C. These are only the questions that are repeated again and again. If you see this here, this is here it is showing you minus I, NO2 group shows you which thing? Minus I and minus I and minus M, right? Both are minus. Here at meta only inductive effect is shown. At para minus I and minus M both are shown. So even if one of them is dominating doesn't matter, it is overall electron withdrawing only, right? Okay? Yes. Now you need something which is withdrawing the electron. So here in B case, the electron withdrawing is less, right? So that means this will be least, B will be least, meta will be least. Why? Because here there is only one effect for electron withdrawing nature. Here you have minus M which will be same to both extent, but here minus I will be more as compared to this. Because here distance is less, so minus I will be more, right? Here minus I will be less. Again distance oriented. That is the reason more minus I means this will be highly stable, right? No, wait a minute. Again same thing. Again same thing. Again same thing. This will be more. But this has hydrogen bonding. Can we see that? This has hydrogen bonding. Again, hydrogen bonding. So, hydrogen bonding will make it less acidic and para will be more acidic. So, it will be C, then you have A, then you have B. So, answer will be CAB. Okay, answer will be CAB is the correct answer here, right? Because of the hydrogen bonding that you can see here. Right? Okay. Yes, everybody. Now let's start doing other questions, right, of benzoic acid. Let's start doing questions of benzoic acid. It's 7:30 already. Okay, we'll do that. Don't worry. Don't worry. We'll do that. Right? Next is, let's see this. This will be, now here one more effect is there, that is ortho. If you see ortho effect anywhere, that will be most acidic. In these cases, you don't have any ortho effect. This NO2, we know that minus I and minus M both are valid, right? In this case, chlorine, minus I and plus M both are valid, but minus I is more dominating. In this case, minus I and plus M both are valid and plus M is more dominating, right? These are the effects here. Now tell me which will be more acidic, right? Yes, everybody, tell me which will be more acidic. If you see, to increase the acidity, we need electron withdrawing. So this has both electron withdrawing, that means it will be most electron withdrawing, so maximum stable. Here you have minus I and plus M. Here minus I is more dominating. Here plus M is more dominating, right? That means here you are providing the electron. Here plus M is more dominating, that means you are providing the electron. When you provide the electron, you destabilize. Electron donating group destabilize it. So answer will be this. Okay? Answer will be A, B, C is the correct answer. Tell me if there is any problem here. Yes, students, tell me if there is any problem here. Yes, everybody? Now, things will get even more, amazing. Because ortho effect is now applied. You see this here, NO2 group ortho effect is valid. Directly say this is ortho effect. because of ortho effect, directly say that A is more acidic. Then we have to compare between B and C. Now the comparison that you are left with is B and C, right? Okay. Now let's talk about B and C, right? Okay. You can write it down in the chat box regarding your doubts, and I'll see, right? Okay. Or you can text me on Instagram or on Telegram regarding your doubts, right? So here if you see on the meta position, there is no mesomeric effect that is valid. So this would be minus I only. And here this will be minus I and minus M, both. So that means this is more electron withdrawing. So this will make more electron withdrawing, means more stability, more acidic nature. So this will make it more acidic. It will be AC, then you will have B. And this will become your correct answer here. Tell me, is that clear everybody? Is that clear? Right? ACB is the correct answer. Just please take care of ortho effect, okay? So here again, ABC. Can you see ortho effect anywhere? Can you see ortho effect? Alkyl chain will show ortho effect. So you can say this, no matter it's plus I, minus I, doesn't matter. Ortho effect means it is going to, because plane will be shifted, right? Plane will be shifted. That is the reason, right? So that is the reason you will say that A is most acidic here. Now out of B and C you have to tell, right? So it will show you plus I here, it will show you plus I here. Plus I decreases the stability, right? Plus I will decrease the stability here. Tell me which is more stable. Plus I decreases the stability, right? So here if you see, right, this is plus I, this decreases the stability, so C should be Acha, we forgot to write hyperconjugation also, na? That is valid. Yes. Here hyperconjugation is not valid. Here in this case hyperconjugation is not valid, but here hyperconjugation is also valid, right? And I told you in the first, when we before talking about these effects only, in the starting I told you about that CH3 will show more hyperconjugation, right? So hyperconjugation will be dominating. That means it will show 2 plus I, and that too hyperconjugation. So it will donate electrons with more extent. That is the reason it will make it even more unstable. So answer will be A, B, and then C is the correct answer. A, B, and then C is the correct answer here. Okay? A, B, and C is the correct answer here. Okay? Understood? Yes, everybody? Yes, everybody, do let me know if that is clear to everyone of you or not. Right? Now this one is same as we did before. Let's see if you can answer this or not. This is A, this is B, this is same as phenol, okay? Now on the para position, minus M minus and plus minus I plus M, both are valid. And what is the overall effect of minus I plus M in case of halogens? The overall effect is that you have fluorine, bromine and iodine. That is the electron withdrawing nature, electron withdrawing group, right? So this shows maximum electron withdrawing nature. That means maximum electron withdrawing means it will make it most stable, okay? Because acidity is directly proportional to electron withdrawing nature, right? Yes, everybody. This is the overall. This is not based on plus minus I. This is based on overall effect of minus I and plus M. But if you have it on the meta position, then things will be different. This is A, this is B, this is C, and this is D. Now on the meta position, you have only minus I. Because on meta position, mesomeric effect is not obeyed only, right? Mesomeric effect is not obeyed only. So this will be minus I. Now, if you see minus I effect because of the electronegativity, fluorine has more, then chlorine, then bromine, then iodine. That means this is going to stabilize it the most. So answer will be ABCD is the correct answer here. Right? Yes, everybody. Do let me know in the chat box if that is clear. Yes, based on electronegativity. Because here we have only minus I. Minus I order is this. This is the overall of minus I and plus M, and that becomes this. Right? So that you need to take care that whether both are applying at meta position, mesomeric is not applied. Okay? Then you have this one. Let's see. A, B and C. Now tell me which will be most stable, less stable. What are the effects that you are going to have here? Yes, everybody? Yes, everyone. What are the effects that you are going to have here? Right? So just give me a second. Okay, so now if you see this here, this is the ortho effect, right? It's a big group, right? So ortho effect will be valid here. Here you will have at meta position only minus I is valid. At para position, both minus I and minus M will be valid. This minus H will be valid. This I told you that CCl3 will show minus H. But here minus I, this is under the exception, where minus I is more dominating as compared to minus H, right? So here in this case, what you will see, A will be most acidic. Now what about B and C? Here you have inductive effect and hyper, that is minus H. Both are valid. Here only minus I is valid. Which will be more here? So if you see, inductive effect is the dominating one, this is dominating one, right? And dominating effect is near here. That means you will withdraw the electrons with more efficiency. That means here you will have B and this is distance, so it will be far away, so it will be then C. So answer will be ABC is the correct answer here. Okay? Yes. Next is this one. Next is this one, ABC. With chlorine, what it will show? Now firstly tell me, when you have chlorine, will it show any ortho effect or not? When you have chlorine, will it show any ortho effect or not? Yes? Okay. So here we can see ortho effect is valid, right? Here we can see only minus I effect is valid because it is meta. This is minus I and plus M both are valid. Plus M being more stable here. Now tell me, based on this, A you can tell is definitely more acidic. But what about others? What about others? Yes, everybody. Everyone in the chat box. Right? Yes. So here if you see, because of ortho effect, A is most stable. Then when you see B and C, this is minus I, right, withdrawing nature here. Here plus M is more valid. So definitely here plus M is more valid. That means it is going to, it is donating. So it is going to decrease the acidity here. So it will be simple A, B and C. Okay, answer will be simple. A, B, C is the correct answer because donation here is more. Plus M, whenever electron donation is there, it decreases the acidic strength. Okay, yes everybody. Now let's see next question here, that is, if you see, you just need to know what I told you there, right? Some important rules and which is showing more, which is showing less, that you should know, right? And this easily you can do this, right? Now if you see this here, you have OCH3, right? This is going to show you ortho effect, right everybody? Now here what you have, this will show you only minus I. Meta is not valid here. This is going to show you both minus I and plus m, but here also plus m is more valid. Wait a minute, have I done it opposite here? Wait a minute, this is opposite I have written here. Wait a minute. Here minus I will be more dominating as compared to plus m, right? Wait a minute, just give me a second. Here minus I is more dominating as compared to plus m, but still if you compare minus I and minus I here, right, this is withdrawing the electron with more efficiency, so this is more stability. Here it is withdrawing the electron with less efficiency, so it is making it less stable, right? Moreover, it is withdrawing it with less efficiency and it is also donating with plus m, so it will become less stable. Answer is same, but that I wrote wrong there, right? Okay, so that I just wanted to correct that. Okay, so yes, here plus m, otherwise plus m is more dominating. So if you see this here, right, because of ortho effect A is more, then what about B and C? What about this B and C? Minus I, that is minus I plus m, right? See now, this is minus I, and because of this minus I, what is going to happen? Because of this minus I, right, it is going to, my throat is paining a lot. Okay, because of this minus I, it is going to withdraw the electrons, right? Here it will withdraw the electrons with less efficiency. Moreover, plus m is more dominating, so definitely it is less stable. So the answer will be A, B, C, right? And according to experimental data, A and B have same pK value, right? That is why they are also equal, right? But if you talk about the actual rules, this is approximately same, right, because of the experimental data, but otherwise if you don't focus on the experimental data, A is greater, and in some books it is also written like this. Okay, because according to experimental data, that is equal, right, everybody? Okay, now next is some more questions. This is A, this is B, and this is C. If you see this here, right, let's talk about this one, everyone. Let's talk about this one. Okay, let's see this now. Here what you have, hydrogen bonding, it will show. After losing, it will show hydrogen bonding. After losing, it will show hydrogen bonding. Because of hydrogen bonding, this would want to lose. It will be like, I want to lose my hydrogen, right? Because after losing hydrogen, I am getting two hydrogen bondings, 2H bond. Here, after losing, you are getting only one hydrogen bond, right? Here you have no hydrogen bond, so definitely answer will be A, B, C is the correct answer, right? Why? Because here you have two hydrogen bonding, more stability will be there, right? Okay, yes. Next is this one. If you see here, in this case you have hydrogen bonding, automatically this will become more stable, right? Because after losing this, you will have hydrogen bonding here, right? So because of hydrogen bonding, this will be more stable, 1H bond, right? Okay, this is making it more stable. Let's talk about the next one. This is A, this is B, this is C, right? Okay. Let's talk about this one. Everyone, is ortho effect getting applied here? Ortho effect applicable? Ortho effect is applicable, right? In all these cases, ortho effect is applicable. Ma'am, now what to do? All have ortho effect. all have ortho effect, but ortho effect is directly proportional to the size of group G. What is the group G? More the size, more will be the repulsions, more will be the ortho effect, right? So that is the reason here size is maximum, so answer will be this, right? Okay. Now here you have another question. Both have ortho effect, but here two ortho effect, but smaller group, but small group. Here you have one ortho effect, but big group, bulky group, really bulky, big group, right? So firstly you will see the number of ortho effects. The one which has more ortho effects will be more acidic, right? More ortho effects, more acidity. If ortho effects are same, then this thing is valid. If number of ortho effect is same, then this is valid. If number of ortho effects are same, then you will talk about the size, but when the ortho effects are more, then you will feel that will be more acidic, right? Okay. Okay. Now that's it guys, that's it. Now let's do some questions. Everybody. Let's do some questions of your PYQ, some general questions, 3-4 will do, and then I'll end the class. Okay? Let's see this everybody. Now let's see this. If you see among the following four compounds, phenol, methylphenol, meta-nitrophenol, para-nitrophenol, so these are the four compounds that you have, right? One is phenol, then there is methylphenol, that means they are talking about cresol, right? So you can put it here or wherever, doesn't matter, I'll tell you why it doesn't matter, right? So here you will have, this is meta-nitro and this is para-nitro. So if you see this here, this is going to give plus I, right? Okay, so it is going to give plus I, it is going to give plus H, right? Plus H. That means it will donate. When it is donating, it will make it really unstable. So second will be least here. Here it is going to withdraw, this is going to show minus I, this is going to show minus I and minus M. So here it will show really very good electron withdrawing nature. So this fourth one, para, will be maximum acidic, right? Now this will also show withdrawing, so it will be better than this. So this will be the third one. And this B which is showing nothing, this A which is showing nothing, so that will be over here. So it will be 4, 3, 1, 2. 4, 3, 1, 2, that is A will become the correct answer here, right? Okay. Let's see next question here. Which of the following will not be soluble in sodium hydrogen carbonate, right? Which will not be soluble? The one which is a very bad, poor acid, that means they are asking you indirectly poor acid. Because acid with Na2CO3, it will form a very good reaction, right? Sodium hydrogen bicarbonate with, and that means NaHCO3 also, or sodium hydrogen bicarbonate or sodium carbonate, it will show good acid. If it is a good acid only, then it will show the reaction. Okay, so it is a bad acid like orthonitrophenol, right? So you have, because of this hydrogen bonding, it will be a very poor acid. poor acid. So that is the reason it will not show, it will not be soluble in NaHCO3, right? So indirectly they are asking you this question here, right? Okay, so answer will be C. Next question is based on this. Let me see, which of the following is most acidic compound? So out of this, when you see, this is showing you -I and -M. This is 3 picric acid. Obviously this is most acidic in nature. Here it is donating, so it will make it less acidic. Here there is no effect, right? Okay. Next is, if you have arranged the following compounds in order of decreasing acidity. Arrange it in order of decreasing acidity. Arrange it in order of decreasing acidity. If you do this, this will show -I and plus M being more dominating. This will show -I and -M, right? This will show +I and +H, right? +I and +H. Oof. I am not able to write +H here. Whatever. Very irritating, sometimes things get. Okay. Now here it is -I and +M, where -I is more dominating. If you see this here, most electron withdrawing is this NO2. So that will be most acidic. So answer will be 3. A is the correct answer. After that, you will have this is most acidic. After, let's see, which has more electron withdrawing nature. This is donating, so this will be least acidic, right? Here you have +I and +H. Here with mesomeric, it is donating. So mesomeric effect is obviously more dominating. So here this will show more donation, so it will be least acidic. After that, you will have second, which will show donate the electrons, but with hyperconjugation and inductive effect. So it will be over here. First one is which is showing +M also, but it is showing -I also. It is better than others, so it will be in the second position. So answer will be E is the correct answer here. Okay. Okay, so now let's see JEE 2025 latest questions of JEE. Okay, 2-3 latest questions we'll do, right? Then we'll end the class. If you see it here, least acidic, you have to tell among this. Least acidic, you have to tell among this. That means where electron withdrawing, electron donation is going on, right? Where electron donation is going on, right? Let's talk about that. So, when you solve this, right, this is the case where there is sp hybridization, right? Whenever, guys, we have sp hybridization, electron withdrawing is maximum. In other cases, if you see, firstly there is OH, sp2, right? This is SO3H, otherwise it's a very good acid only, right? Here this is sp3. So this is the only carbon which is sp hybridized, right? Because of its sp hybridization, we know that sp, then sp2, then you have sp3. Because of its very good -I effect, electronegativity, that is the reason it will destabilize it to the maximum. Wait a minute. Carbanion, least acidic. If you talk about this thing, this will be COOET here, right? Wait a minute. Terminal alkyne, no? Yes, I forgot to see this COO. This is actually This is C triple bond CH. This is C CO C double bond O OET. So here what is happening, this terminal alkyne is sp, right? That's why this will be acidic in nature, right? This will be acidic in nature, so its conjugate base will be less stabilized if you see this here, right? This will be ET O, this will be C double bond O, C triple bond C negative, right? That will be the conjugate base here, right? Right? That will be the conjugate base here. Here, this particular carbon ion that you are forming, it is not at all being stable, because this negative charge here is not showing any kind of resonance. No resonance it is showing here, right? No resonance it is overall going on. But if you see others here, right, in other cases it loses H positive, it will show resonance. Here it is not showing resonance, but here what will happen, this COH, it will also be like not unstable here, right? But if you see this here, it will lose this, it will also show very good resonance, right? And that is the reason we can say D is the correct answer, that is B is the correct answer here, right? Next question is, for a given compound, the correct order of increasing pKa value. Now, pKa value is inversely proportional to Ka, that means inversely proportional to acidity. So, you just need to tell, for a given compound, correct order you need to tell, right? So, just write down all the values here. This is ortho meta. From this is also, this is meta, so this only minus I is applied. This is ortho meta, here only minus I is applied, okay? This is para, so this is minus I and minus and plus M both are applied, plus M being more dominating, right? Here you have para, so it is minus I and minus M both are applied. Here no effect is applied. So if you have a very good electron withdrawing effect, that is B, that is going to make it most acidic. So B will be most acidic here, right? Okay. So let's see the options here. Let's see the options here. B will be most acidic, that means pKa value of B will be minimum here. So answer will be B is the correct answer here, right? Okay. From that directly you can tell. Right? Just by knowing that B is most acidic, that's why its pK value will be least, you can tell that the answer will be B is the correct answer. Okay? Yes, everybody? Yes, everyone in the chat box. Out of NO2 and OCH3, right? Then you will have NO2 here, right? Then you will have OCH3 here because of the minus I effect here. Here you are also donating, so it will be less stable as compared to that. And there, here you have no effect, so it will be in the end, right? So that's how you will have B as the correct answer here, right? Just pK and Ka order is opposite, that you have to remember, right? And this is a very simple question, that is your JEE 2024 question, right? Now in this question, they are asking you the acidic strength order. They have given different alkyl chains, and let us see in the chat box how many of you are able to answer this as your homework. So very rare students do their homework. Let's see today who will do it. Let's see today, right? I daily wait for your homework, but let's see who will do it today, right? Okay, so take a screenshot of this one and let's see who will answer this, right? And before going, students, remember that MVSAT scholarship form is now last few dates we are left with, right? The exam is going to happen on 4th, 5th, 11th and 12th of October, that is Saturday and Sunday. What you will get after that? Firstly, if you get into 2.5 lakh students, you will get 100% scholarship on all the Vedantu courses, 150 crore worth of scholarship and 2 crore worth prizes like iPhone, iPads you will get, right? Now, Ma'am, do we need to pay any fees to register ourselves? No, right? You don't need to pay. You can select any of the dates, but the seats are almost filled, right? That's why registration is going to close soon, right? Okay, yes. Okay then students, I'll see you all in the next class, right? And you can visit your nearest Vedantu centers, right, to give the test, right? Okay. Okay then, I did homework but joined class late. Okay Abhishek, but homework, I will only accept that you have done homework if you write your homework. Otherwise, how will I get to know that you have done? Okay, so write it down in the comment section. Right? Okay? Yes. Okay then guys, I'll see you all in the next class, that is tomorrow. Now, again, this throat is not well. So I'll see if I take the class tomorrow or on Sunday, right? But either tomorrow, if I need rest tomorrow, then I'll take the class on Sunday. Okay? Yes. Okay then guys, bye bye. Take care. See you all in the next class. Bye bye.